Alright, so day 4, we're going to take the idea of similarity and size being proportional to the next level and talk about how we can apply that to some polygons. Now, just to recap, similar polygons, two polygons are similar if the corresponding angles are congruent and the corresponding side lengths are proportional. If two triangles are similar, the symbol that we use is that. So remember, this is our congruent sign. Similar doesn't have the equal part, and that should kind of make sense because similar shapes are not the same size. Like, not all the side lengths are not the same, but the angles are. So we don't use the congruent symbol, we use only part of it. So for this activity out here, we're just kind of going to run through it together. We're not going to use any tracing paper and all that. So we'll just kind of talk about it. So the corresponding angles in this triangle are congruent. So yes. The triangles are clearly not congruent because, we have a side length of 10 right here. No side length in triangle EFD is 10. So no. However, the triangles have proportional sides. So let's look at now number 2. We'll skip that one. AB is 10. DE is 15. Well, we can simplify that fraction to 2/3. BC is 8. EF is 12. That also simplifies to 2/3. Then we have CA, 12, over FD, which is 18, and that also simplifies to 2/3. So they all have a common ratio, which is our scale factor, which, remember, that's our K value. So we would be able to say that K equals 2/3. And since they're all equal to 2/3, by that awesome transitive property that we all know, we have AB over DE equals BC over EF, which equals CA over FD. Now, to tell which angles are congruent, we got to match things up. So angle A up here matches up with angle D. And you can kind of look at it as, in our statement, A is first, D is first. A is last here, D is last there. So A and D go together. B and E go together. And then CF. C and F go together. So it's kind of like what we did when we're talking about congruent triangles and lining things up. So then the similarity statement, and just like with congruent statements, you could have multiple correct similarity statements. So I will go with triangle ABC is similar to triangle DEF. Alright, these vocabulary words, we'll talk about these later when I come back. We're just know. Just know. Alright, let's flip to the next page, please. So we're going to be using these similarity properties to find out lengths of shapes, or find out lengths of segments in shapes, I should say. So in this diagram it says triangle JKL is similar to triangle EFG. Find the length of the median KM. So we're trying to find this length here. Well, KM is going to correspond with FH over here. So we're going to set up KM over FH. And now we want to find a ratio of two sides that we know. So look at JM and HG. Well, what we need to do is say, okay, JM is 48. Let's just write it down first. JM over HG. And again, the order does matter. You'll notice that JM is in this triangle, and so is KM. And those appear on the top of both of my fractions. Again, it's just the way I like to do it. It makes things easier for me. So then we will substitute the values that we know. We know that, let me erase that. We don't know what KM is, so we can leave that as X over FH. FH is 10 equals JM is 48 over HG, which is 40. We can cross multiply and we get 40x equals 48. And when we divide both sides by 40, we get that x equals 12. So KM equals 12. So I know that may have sounded a little bit confusing, especially how we set up this over here. But the biggest takeaway to get from that is, how I do it is the number on top of one fraction has to be come from the same place in the other fraction. Right. If corresponding sides have a common ratio, then that is the scale factor. So we're going to determine whether these polygons are similar or not. So we have A, B, C, D, and JKM. So that means that angle B should be congruent to angle K. Is that true? Angle B is right here. K. They each have one of those angle markings. So yes, that's true. Angle C has two markings. Angle L has two markings. C and L go together, okay? D and M should go together, okay? D and M go together, good. And look at angle A and J are both right angles, so those are congruent. So far, all four angles are congruent. We then need to check the sides to see if they're proportional. So now we know the corresponding angles are congruent. And what we need to figure out, write a statement of proportionality for A, B, C, D to J, K, L, M. Basically what that means is that when we do step 3, all these fractions, all these sides must equal the same thing. So I don't want to waste our time writing that out. So AB from our picture is 8. JK is 14. So that simplifies to 4 over 7. AD, in our picture, AD is 12, and JM is 21. That simplifies to 4 over 7. Now, you may be tempted to stop right here. Don't do that. You have to show it true for all 4 sides. So CD is 8, LM is 14, that reduces to 4 over 7, BC is also 8, and KL is also 14, which simplifies to 4 over 7. So since all of the ratios simplify to 4 over 7, the corresponding side lengths are proportional. Which makes that the two shapes are congruent. Or not congruent, I'm sorry, similar. So ABCD is similar to, I'm going to make sure I have the right order, JKLM. JKLM. And the scale factor was 4 over 7, because that is what we got every single time we That's what we got every single time we simplified our fractions. Alright, last example, and then we're done. In the diagram, we are told that these two shapes are similar. So we're going to find a common ratio. You could pick any side that you want. I like dealing with even numbers, so I'm going to go with FJ and LP. So I'm going to do 20, I'll write out FJ over LP, which is 20 over 16. And that will simplify, if we divide both of those by 4, we get 5 over 4. So that is our scale factor, our common ratio, 5 over 4. Now, find the value of x. There's a couple ways you could do that. You could do it with the scale factor. I don't like doing it with the scale factor because with the scale factor I may mix up the fraction. I like to do it how we solved example number 1 up here. So what I want to do is I'm going to say 40 over x, because those are corresponding sides. 40 over x equals, and I'm going to pick another pair of sides in my shape. It doesn't matter which ones. So I'm going to do 15 and 12. And again, because I put 40 on top of my first fraction over here, 15's got to go on top of my second one. To me, that just makes the most sense and it's easiest to remember. So then we will cross multiply this, and when we cross multiply, we get, let me get a color, 15x equals 40 times 12 is 480. And then when we divide both sides by 15, we get 32. And that is our answer. So I'm hoping that as you're going through this makes more sense. Like I said before, reach out if you have any questions. I will be more than happy to help you. Make sure that you have all your notes done for when I come back. And I hope you enjoy the long 4-day weekend. See you guys soon.